Alright, these are your notes for section 6.7 on solving quadratic inequalities. Now, you've already watched the video for graphing quadratic inequalities, and the major differences in how the problems look is that graphing a quadratic inequality has a y in it. It's concerned with the parabola and shading. When we're solving a quadratic inequality, it's going to have 0 instead of y. Okay? When we're solving a quadratic, there's some differences, some major differences in how we show our answer, how we write the answer. When we graph them, we're really concerned with the parabola and how it looks. Okay? When we're solving, not so much, and that's going to be one of the major differences. Now, before we get going, I want to make sure we remember our inequality signs. We have greater than, less than. These are strictly greater than and less than, so these are going to be dashed. Now, it does tell us how to write our answer, so we are going to pay attention to the parabola, whether it's solid or dashed. We're just not concerned with so much how it looks. We're not going to find the vertex on these. We're just going to freehand these a little more, okay? Because we're really only concerned with the x-axis part of it. So, less than, greater than, strictly less than, greater than, dashed. If they have equal to, then we're going to have solid parabolas, and that's important when we graph them. Alright, now let's jump into some of the differences. One of the major differences is we're only concerned with the roots. Your roots are your zeros. Okay? We're not going to find the vertex or the axis of symmetry on these when we're solving them. We are going to find the roots and the zeros, which means we're going to factor. Okay? We didn't factor when we graphed them. When we graphed them, we found the vertex, and we made a table, and we went through that. We are not going to do that when we solve them. Okay? Major difference number one. Second difference is that we're really only concerned with the x-axis. Okay? There's only one variable. Because remember, our zero is now, or our y is now a 0. We have no y when we look at these problems. So the only variable we have is an x. So we're really only concerned with the x-axis, and that helps us write our answer. Okay? Now, I'm going to show you, because we're only concerned with the x-axis, there's two types of answers you can get. Our x-axis is the line I've drawn in here, and we have a parabola for each one. First type of answer is called a branch. Second type of answer is called a bridge. Now, a branch is when we have the outside of the parabola shaded on the x-axis, because we're only going to deal with the x-axis. So the outside part is shaded. We call it a branch because it goes to the left and to the right. They don't connect. It's like a tree branch. One goes to the left, one goes to the right. Okay, they're going everywhere. These are going to go to the left and to the right. The bridge is when we have the middle of the parabola, the inside of the parabola connected. We call it a bridge because it connects the two sides. Okay? So those are the two types of answers we can have. Now, we do have to go through and test and graph in order to get there, but again, we're only really concerned with the shading on the x-axis, whether it's a branch or a bridge, not necessarily the whole parabola. So let's look at example 1. Example 1 is x squared minus 4x plus 3 is less than 0. Okay, notice we have 0 there. That tells us we're solving it instead of graphing it. Okay? I told you earlier that we're not really concerned with the parabola. We're not going to find the vertex. We're not going to find the axis of symmetry. We're not going to make a table. We're just going to jump right in and factor because all we want are the roots. So 3 goes on top because a times c, 1 times 3 is 3. B is negative 4. It goes on the bottom. I need two numbers that multiply to 3 and add to negative 4. Okay? These numbers are going to be negative 1 and negative 3. Now, they're both negative, and that's okay because two negatives multiplied together make a positive. Negative 1 times negative 3 does give me positive 3. And when I add them together, I get negative 4. I can jump right in and use my shortcut. I can go straight to factored form. X minus 1 and x minus 3. Okay? Go straight there because a is 1. I'm going to change the problem for a second, and I'm going to say equals 0 because I'm finding the roots. It will change it back. This is the only time we're going to change it to equals 0 is when we're finding the roots. And then we'll go back to the inequality sign here in a little bit. So x minus 1 equals 0. I need to have it equal to 0 so I can use that zero product property and pull them apart. And I end up getting x equals 1 and x equals 3. Those are my roots. And remember, when we have a parabola, a quadratic, the roots are where they cross the x-axis. So I know that my parabola crosses at 3 and 1. I also know I'm going to have a dashed parabola because it's strictly less than, and my parabola is going to open up because a is greater than 0. A is positive. Okay, so now I'm going to freehand my parabola. Something along those lines. Okay? It doesn't have to be perfect because, again, we're only going to be concerned with the x-axis part of this. Now, we do have to test it because we need to figure out whether it's going to be a branch or a bridge. And to test this, we choose a number that's on the x-axis. Okay? That's important. It has to be on the x-axis and needs to be inside of our parabola. Okay? If it's true, then, when we plug our number in, okay, again, we only have to pick an x-axis because we only have one variable. We only have x. So we're only going to pick an x value to test here. If it makes it true, then we're going to go with the inside, which means we have a bridge. Okay? Means we would shade in the inside of the parabola on the x-axis, giving us a bridge. If it's false, then we'll shade the outside of the x-axis, and that gives us a branch. Okay? So let's pick our test. We're going to test anything that's inside there. A 2 is an easy number. It's a whole number, and it's definitely inside of our parabola. So let's test 2. Test x equals 2. So now we have 2 squared minus 4 times 2 plus 3 is less than 0. 2 squared is 4. Negative 4 times 2 is negative 8 plus 3 less than 0. You can do the rest of this in your head. Negative 4 or 4 minus 8 gives us negative 4 plus 3 is negative 1. Negative 1 is less than 0. That's true. So that means we end up having a bridge for our answer. Okay, so the first part of our answer here is that we have a bridge. We're going to shade that in on our number line. Okay? I shaded the inside of that parabola along the x-axis. Now I'm going to redraw my answer. I have a dashed parabola, so really I would have an open circle at 1. Here's my number line. Then I have 2. And then I have another open circle at 3. And I've shaded in that. This is the x-axis. This is what it looks like. Now I have to write my answer in set builder notation. Okay, and remember set builder notation, brackets, inequality, close your brackets. So I have to change what we've drawn here on the x-axis into an inequality. Well, now we've shaded between 1 and 3, which means my x is between 1 and 3, and I'm going to use the same inequality sign from my problem. So it's less than. And I'm going to put in the numbers. So now I have 1 is less than x is less than 3, and what that means is that I've shaded in the x's between 1 and 3, but not including 1 and 3. And that's what the graph here is. That's what it means. So my answer for the problem, this is how I'd say it verbally, is that any value for x, any x that's going to make this problem true, has to be between 1 and 3, but not including 1 and 3. Okay? That's what I would say. That's the answer to the problem. I only want the x values that make this true, and those values happen to be between 1 and 3 and not including 1 and 3. Okay? And that's what this tells us here. So my answer for the whole problem is that we have a bridge, I've shown it on the graph, and I've written out my inequality. That's what I want to see. Okay, we're going to do another example. We're going to show all of this again. In example 2 here, we have 0 is less than or equal to negative 2x squared minus 6x plus 1. So the first thing we need to do, we're going to jump right in, and we're going to factor. A times c is going to be negative 2 times 1, and b is negative 6, goes on the bottom. I need to come up with two numbers that multiply to negative 2, but add to negative 6. Well, 1 and negative 2 multiply to negative 2, negative 1 and 2 multiply to negative 2. Those are my only two choices. And neither of those add to 6. That tells me that this is not factorable. Okay, and that may happen. You may see problems like that on your homework, where it's not factorable. That doesn't mean we stop. That means we're going to use the quadratic formula. So we have to think back earlier in chapter 6 where we had the quadratic formula. Our quadratic formula is x equals negative b plus or minus square root b squared minus 4ac all over 2a. And we're going to plug in our a, b, and c and simplify this, and we're going to find the roots this way. This means, since it's not factorable, that our roots are not going to be rational. They may be irrational or complex. They're probably going to be irrational because we're looking for where it crosses the x-axis. If we have complex answers, that means our parabola doesn't cross the x-axis, and we don't want that. So they're probably going to be irrational, which means they contain a square root in them. Okay? So let's jump in. Let's list out a, b, and c. A is negative 2, b is negative 6, and c is 1. So as we plug these values in, a negative 6 plus or minus the square root of negative 6 squared minus 4 times negative 2 times 1 all over 2 times negative 2. Well, a negative 6 is positive 6 plus or minus the square root. Negative 6 squared is 36. And then we have negative 4 times negative 2 times 1. Two negatives make a positive, so positive 8 times 1 is still positive 8 over 2 times negative 2, negative 4. We keep going. 6 plus or minus the square root of 36 plus 8 is 44 over negative 4. To break down 44 now, 44 is really 11 times 4. 4 is a perfect square. So out in front, I'm going to put the square root of 4, which is 2, square root 11, over negative 4. Now at this point, you need to simplify this. There is a greatest common factor. There is a number that goes into 6, 2, and 4, negative 4. And that number is 2 because they're all even. So 6 gets divided by 2 and becomes 3. 2 divided by 2 is 1. Negative 4 divided by 2 is negative 2. So our answer ends up being 3 plus or minus square root of 11 over negative 2. Now I didn't have to put the 1 out in front of the square root. It's understood that it's there. Okay? I really have two answers here. 3 plus the square root of 11 divided by negative 2, and 3 minus the square root of 11 divided by negative 2. And we're going to figure out the approximation for these two so we can put them on the number line. Start with the square root of 11. Square root of 11 taken out to the hundredths place is approximately 3.32. So I end up getting 3 plus 3.32 divided by negative 2 and 3 minus 3.32 divided by negative 2. Well, 3 plus 3.32 is 6.32 divided by negative 2 ends up being negative 3.16. So that's one of my roots, approximately. The other one, 3 minus 3.32 ends up being negative 0.32 divided by negative 2 gives us 0.16. So there's my other root. We're going to graph these. Negative 3.16 is right about there, and 0.16 is right about here. Now, I know I'm going to have a solid parabola, and it's going to open down. The reason it's down is because a is less than 0. If we look here, a is, it's right there, negative 2, and that's less than 0. So my parabola is going to open down. Looks something like this. Now I have to test a number. Remember, I want to choose a number that's on the x-axis and inside the parabola. Well, negative 1 looks like a good number, so I'm going to say x equals negative 1. Plug that in. 0 is less than or equal to negative 2 times negative 1 squared minus 6 times negative 1 plus 1. Negative 2 times negative 1 squared becomes positive 1. Negative 6 times negative 1 becomes positive 6 plus 1. So now I have negative 2 plus 6 plus 1. Yeah, that ends up giving me 5. negative 2 plus 6 ends up being 4, plus 1 is 5. So I end up getting 0 is less than or equal to 5, which is true. And if it's true, that means I have a bridge. So I would shade the inside of that parabola along the x-axis. And I'm not quite done yet. I'm going to redraw what this looks like. I'm going to give the exact numbers here. This is 3 plus the square root of 11 divided by negative 2, all the way to 3 minus the square root of 11 divided by negative 2. And I've shaded between them. Okay, notice I used closed circles because my parabola was solid. So this tells me that I'm going to go from 3 plus the square root of 11 divided by negative 2 less than or equal to x less than or equal to 3 minus the square root of 11 divided by negative 2. I've shaded all of the x's between those two numbers, and that's what my inequality written out there tells me. Okay, so that's the solution. The solution, 3 parts, that I have the bridge, I've written it out, and that I've graphed it on the number line. Okay, now I know that that's tricky, that's hard to understand. Hopefully it makes sense. If you do have questions, I'd like you to either go back and rewatch the first example or the second one. The second one is more difficult because it has the quadratic formula. So just know that if you see that, you're going to have a lot more work involved. Okay? Rewatch the examples, and if you still have questions, bring them to class next time.